In this online lecture, we're going to discuss buffer solutions. And what we want to know about a buffer here is that first, they resist changes in pH. We're going to see two, buffers are made up of a weak acid and its conjugate base most of the time. You can also make up a buffer by a weak base and its conjugate acid. We're also going to see three, how the buffer resists changes in pH. It does it by the weak acid consuming any hydroxide ion added to the solution, and the conjugate base consumes any hydronium ion added to the solution. So let me show you how that works here. Let's say you have a solution that has a buffer. Here's our weak acid HA, and here's his conjugate base A-. Now, how is it that these two species resist changes in pH? Well, remember, one way to change the pH is add a strong acid or pure H+ into the solution. Let me show you what happens here. After this is added in here, then the A- combines with that H+, and think about it, the A- is attracted to the H+, and what happens is that it comes together and makes HA, which notice happens to be our weak acid of our buffer. But the key point is think about it this way. The A- is almost like vacuuming up all the H+ that's added and converting it into HA, therefore removing H+ from the solution. Now remember, that's not the only way to change the pH of a solution. You could also add a strong base or pure OH-. In this case, it's the HA of the buffer that takes care of the OH-. Since he's a weak acid, what he does is simply protonate the oxygen of the OH, turning that into water, and as a side product, we're also getting A-. In this case, HA is vacuuming up all the OH- that gets added to this solution, therefore removing OH from the solution. This in turn means that the pH will remain constant for this solution. Now keep in mind, buffers have a limit. It depends upon how much HA and A you have in solution. For instance, if I keep adding a bunch of H+ and I run out of A- to combine with it, then at that point you have exhausted your buffer and the pH will now start to change. So what have we learned here about buffers? Key point number one, that they resist changes in pH. And number two, they're made up of a weak acid and its conjugate base, or it works just as well with a weak base and its conjugate acid. And we also saw how they resist a change in pH, and that is the weak acid consumes any hydroxide ion added to the solution, and the conjugate base consumes any hydronium ion added to the solution.